Okay, if you checked out that last video, you saw different ways to graph 3 different types of equations. So again, the whole purpose of it is you see something that we know is linear, you should be able to graph it. If you don't like those graphing instructions on before, then know that you can convert any equation to one that's easier to graph. So I'm going to show you really quick on these how to convert to what I'm going to argue is the easiest equation to graph, and that's our slope-intercept, y equals mx plus b. It's the easiest equation to convert to since y is isolated. We have a y by itself. Plus, we have these 2 very basic instructions. In our red area here, that plus b, that little straggler at the end, that's our y-intercept. So on a graph, you just got to plot that y-intercept wherever it belongs, and then use the m feature, use that slope, to use from this data point, go rise and run, produce one more data point, and now you have your graph. So I could go, say for instance, up 3 over 2, and plot my new point. As soon as I have those 2 pieces of information, I can make a graph. I have the y-intercept, make a point, use the slope from there to make your second point, there's your graph. So if we can convert any complex equation to look like this, it becomes super straightforward to graph because all the data is right there. There's the y-intercept, there's the slope, connect them. So I'm going to go through a couple different ways and a couple different things to see different equations and how to convert. A lot of the times, this is not going to be every specific piece of information, but you just got to think about, okay, well, what can I do to get y isolated and to get it in a form that looks like this? Y equals mx plus b. First, you might see something in point-slope form. So in point-slope form, which we have right here, you have a y value, you have an x value that makes an ordered pair, and you have a slope that's connected here to that x quantity. So I'm just going to pull that slope down right away because I know 1/4 is my slope. Then I'm going to use my x and y values, x and y values to make an ordered pair. If our original equation is x minus 3, then I'm just going to pull that number straight out and know that 3 is my x value. I know in my original equation it's y minus y1. So since I have a plus value here, right there, I know that I need to kind of switch around the value for that 7. So I'm going to put my value as -7. Because if I write y minus -7, if I was putting it into point slope, I know that's the same as y plus 7, because I can keep change it. Now that I have all my things there, I could graph in point slope form. However, that's not what we're doing here. We're not graphing in point slope form. We're simply saying, okay, well, if I have a point slope equation, can I write it in y equals mx plus b to graph that way? Absolutely, you could. We practiced this last time, and it all kind of comes into that conversion process. Again, our goal is to get y by itself. In order to do that, I would need to subtract 7 at some point, but I can't subtract 7 from this side because it's not simplified yet. I don't know what to subtract 7 from. So before I even subtract 7, I'm going to use that distributive property. I'm going to distribute the 1/4 to both terms inside the parentheses. So now on the left side, I have y plus 7 still because that's been untouched. 1/4 times x is 1/4 x. And then now I'm just going to put in that subtraction sign just to kind of keep my ideas and organize myself. But now I'm going to take what's 1/4 times 3. And I know I can write 3 as 3 over 1, and then I can just multiply straight across. 1 times 3 is 3, 4 times 1 is 4, so now I have minus 3/4. So next, what I'm going to do is I'm going to add, now I'm going to subtract 7 from both sides to get y isolated. So when I subtract 7 from there, now I'm one step closer to getting y isolated. What I need to do next is subtract 7 from this side as well. So now really again what I just need to solve is what is, and I'm going to kind of put this as plus negative to remind myself, this is -3/4. And I need to subtract 7. So now I guess really what I'm looking at is how can I subtract things that are different denominators. So I'm just going to kind of pull things together, make some different denominators or make similar ones in order to get there. It's a complex problem for this type of specific problem, but it's going to help me in the long run. So I'm going to make 7 equal to something over 4. And so really I'm just saying how many fourths is 7 wholes? And really it's going to come down to that's 28. Because if I look at breaking 28 things into 4 groups, well, each group has 7, 20 divided by 4. So I know that -3/4 minus now 28/4, because that's 7 wholes. And again, if I need to see that again, 7 over 1 is the same as blank over 4 times 4 times 4. That's where I got my 28. So now I can just simply say, okay, well, now I have my common denominators. Now I can just subtract my numerators. So now I'm just looking at -3 minus 28. Thinking about what I can do with positives, I go plus negative, and I get -31. So now I would get an answer here of y equals 1/4 x minus 31/4. And now I can also think about that, okay, well, what does that really mean for y-intercept? And I can kind of think about writing that as a mixed number. Y equals 1/4 x. 4 goes into 30 7 times. So that's 7. And what's left over after that? Well, that's 3/4. 7 3/4. And again, if I'm looking at really what I just did there, if I'm taking -3/4 and subtracting 7, well, yeah, I'm going to end up with -7 3/4. So now on a graph, I would know where my y-intercept goes, and I from there could go up 1 entire whole and then over 4, and I could graph. So now I just have everything written in y equals mx plus b form if I wanted to use that form to graph. Our final example, this one isn't always the easiest, but anytime we see standard equations, we know if we're going to graph it, I can use x and y intercepts. That's a long process. So sometimes it might help to convert to slope-intercept. So you can just plot the y-intercept, use the slope to get to that next value. Again, my goal then is to get y isolated. If I think about what needs to happen and what I need to get rid of, well, I might need to lose this plus 12x. I might also need to use this multiplication of 4. So I'm just going to start. I'm going to subtract that 12x away, because if I get that away, I'm left with just 4y on this left-hand side. But I need to subtract 12x from over here. Don't know what x is, so now I really can just say 24 minus 12x, because I can't simplify those two numbers anymore. They're not like terms. So now if I'm going to get y isolated, I just simply have to divide both sides by 4. But if I'm dividing this entire side by 4, I need to divide all terms by 4. So that's 24 divided by 4 to equal 6, minus 12x divided by 4, 3x. So now I get an equation of y equals 6 minus 3x. And if I'm looking for y equals mx plus b form, I know I can just kind of switch these things around as long as I'm feeling comfortable knowing what's negative. So I could say y equals -3x plus 6. And now I have my slope-intercept form that I can graph, and I can start to get an idea of where things are. Hopefully this helps with some conversions. Be ready to kind of manipulate to get y isolated if that's the best way for you to graph.